Hi everyone. In this video I'm going to demonstrate how to perform confirmatory factor analysis with Stata. Before we get started, let me just mention that the version of Stata that I'm currently working with is version 14. And also underneath the video description you will find this link right here. This is a link to the Stata data file that you can download to follow along with the video presentation. Additionally, you'll find a PowerPoint that contains more information related to interpretation of results. So the example I provide here is based off a presentation by Byrne in her book Structural Equation Modeling with Amos. So in that book she demonstrates how to perform CFA with items from the Maslach burnout inventory. So the items associated with this inventory are designed to tap emotional exhaustion, depersonalization, and personal accomplishment. So I'm not going to be using all of the items from Byrne's presentation. We're just going to use a subset of them to give you a basic idea about how to perform the analysis in Stata. Now before I open up Stata to demonstrate, you'll notice that right here on this slide I've got a model drawn out. This is using the Stata Diagrammer, and so you'll notice that we've got basically boxes, arrows, and ovals. So the ovals are essentially latent variables. So in SEM notation, ovals represent, or circles represent, latent variables. These are not directly observed in the data. Boxes represent manifest variables, and so right here you can see that we have these boxes are basically indicators of the latent variables within the model. You'll see that to the left of each of the boxes you'll see a circle with an arrow pointing to it, and that is an error term associated with each of the indicator variables. So for instance, this circle right here is essentially reflecting the variation in the first item from the inventory that's loaded onto the emotional exhaustion factor. You'll also see that we have double-headed arrows in several parts of the model. So this double-headed arrow right here is essentially specifying a correlated error between the EE3 variable and the DEP1 variable. Then over here on the right you can see that we have a double-headed arrow that's correlating the emotional exhaustion variable with the depersonalization variable, and then depersonalization with accomplishment and emotional exhaustion with accomplishment. So let's go ahead and open up Stata and draw out our model. So here I've opened up Stata. Just taking a quick look at the data set, we'll just go under Data, Data Editor, Edit. So you can see I've got EE1, EE2, E3, E4. That's for emotional exhaustion. Then I've got PA1, PA2, PA3, PA4, which is for personal accomplishment. And then I've got DEP1, DEP2, DEP3, and DEP4, which is reflecting depersonalization. So we'll go ahead and go under Statistics, go down to SEM, Structural Equation Modeling, Model Building and Estimation, and the diagrammer opens up. So what I'm going to go ahead and do really quickly is kind of increase the drawing area that we have right there, and also I'm going to adjust the canvas size a little bit more. What I'll do is just kind of go down here. I'm just going to select 8 for size, 8 by we'll just do an 8 by 8 inches and click on OK. And so now I've got a lot more drawing space to work with. So let me also note that as I'm drawing, I'm probably going to pause here and there just to keep things from going too long in terms of the presentation. Alright, so also over here to the left of the canvas you can see that we've got various icons, and these are used to draw out the basic model. So the first thing that I'm going to do is click on this button right here, and just kind of highlighting it, you can see it says Add Observed Variable. So within the model I actually have 4 indicators per factor. So you can see that once I've clicked on this, I now have a box. So I can just kind of orient the box here. There's the first one. That's the first indicator. That will be EE2. This will be EE3, EE4, and then we'll go all the way down for the remaining indicators. Okay, so now I've gotten all the boxes in there, so I'm going to select off. I'm just going to click this little button right there. So now we're ready to go for that. So next, under variables, I can actually click on a box, and where it says variables, I can then bring my names in. So I can just there's EE1 right there. Then we have EE2 that's in that box. Then EE3, and then EE4, which will be this one right here. Then I've got the depersonalization, so there's DEP1. Then we have our DEP2, our DEP3 right there, and then we'll have our DEP4, which I'll kind of scroll down just a bit there. Then we have our remaining ones, which will be the Personal Accomplishment 1, Personal Accomplishment 2, let me find that, there it is, then 3 and 4. So there's Personal Accomplishment 3, and then we have our Personal Accomplishment number 4 right there. So next, just kind of selecting off, I'm going to select on Add Latent Variable. So I'm going to click this button right here, and so then we've got basically our first latent variable, our second one, which will be right, I'm just going to put it right here, and then our third one will go right here. So next I can click on this little add path and draw in the factor loading. So we'll just kind of reselect that right there, and then just draw from each of our latent variables to each of the indicator variables, so that you can see as we're drawing, the error terms highlight and become active. So you can see this is for the second factor right here. Oops, right here. So I'm just going to keep drawing in, and then we'll do the same for this last one right here. So now we've got our drawings from the latent variables to the indicator variables along with the error terms. So next, let's go ahead and name the latent variables. So what I'm going to do is select off right here and then just kind of click on the first oval, and I'm going to type in emotional and then hit enter, and there it is. And then we'll do the next one. This one will be basically DEPERS, just to kind of keep it simple, and then hit enter. And then right here we'll type in ACCOMP and hit enter right there. So next up, we want to add in the covariances among the latent variables and then that error term. So I'm going to select add covariance right here and essentially highlight and drag down, and you can see that now we have our double-headed arrow there, our double-headed arrow that appears right there, and then our double-headed arrow that will appear right there. Then we're going to add in the covariance between the errors for EE3 and DEP1. Now, just so you know, if I draw down right here, the arrow, the double-headed arrow will look like this, and that doesn't look very nice. So I'm going to delete that. I'm just hitting the delete button, and I'll just draw up, and so now you can see it appears as well. So I'm going to select off at this point, and now I want to fix that first factor loading to 1. So what I'll do is I'll click on this button right here, and you can see it, the arrow highlights in blue, and up here where it says beta, I'm actually just going to type 1 and then hit enter, and so that first loading has been fixed to 1. And this is essentially a strategy that's used in order to scale the latent variables when you're running your CFA models. So next I'll do the same thing for this next one. So I'm highlighting this path, or this factor loading, and I'm going to type 1 right there, and then we'll do the same thing for the last one. And really, it doesn't have to be the first item necessarily that is fixed to 1. It can be whichever item that you want. But I'm just kind of showing you right here that we're just fixing the first item, the loading for the first item associated with each factor to 1. So now we're ready to estimate our model. So I'm going to go up to Estimation and click on Estimate right here, and you've got this box that comes up. The method, you can see the default is maximum likelihood. There's also a option for maximum likelihood with missing values. So if you have missing values and you select maximum likelihood, then any cases with missing values for those variables will be listwise deleted. So if you have missing values and you don't want to lose that information, you want to use full information maximum likelihood, then you can click on maximum likelihood with missing values. But I'm just going to go ahead and keep it simple by sticking with maximum likelihood. It actually turns out that the data set doesn't have any missing data, so we're going to stick with that. let me see, under reporting, let me just also note, we're not going to click on it just yet, but if you want standardized coefficients and values appearing in the diagram instead of unstandardized coefficients, and you can click on this button right there. So I'm not going to do that for this particular demonstration. We'll just go back under model and then click OK. And so now the model is being estimated. So you'll notice that now we have our unstandardized estimates appearing in the diagram. So you'll notice that first factor loading is set to 1, and notice that as you click on any given parameter to the right, you'll get the unstandardized coefficient and test statistics, and then also the standardized coefficient and test statistics. So all that information appears under the details button on the right. So you'll see this first loading right here is already fixed. So there's the fixed loading, fixed coefficient right there. So there's no test that's being carried out with respect to that. The standardized factor loading right here is 0.8811, and so that's essentially what that is right there. Notice too that if we click on the double-headed arrow, you'll see that up here we've got the covariance. So this is the covariance between, in this case, emotional exhaustion and personal accomplishment, along with the significance test. You can see that we have a statistically significant negative relationship between emotional exhaustion and personal accomplishment. The correlation between those would be this value right there. So next, let's click under. Let's just go under the actual output in the standard Stata interface. You'll notice that at the top right here, the model has been run. This is essentially the syntax. If you wanted to run using just the syntax with the model, then this would be an example of what the syntax would look like. So if you're trying to learn a little bit about syntax with SEM, then that's where you can go. You'll see that as we scroll down, you can see that we've got estimation method ML, that's for maximum likelihood, and then you've got a box that contains the coefficients, standard errors, z-values, and p-values, as well as a confidence interval. So you can see right here, for the EE1 variable, the factor loading is fixed to 1. That's why this says constrained, and there's no test statistic associated with it. With EE2, you can see there's the unstandardized factor loading, the standard error, the z-value and p-value, and so forth. And just kind of blowing it up a little bit, actually in this presentation the items are kind of in a weird order, but there's basically the EE1, EE2, EE3, and so forth. But you can see right here that essentially all of the factor loadings are statistically significant, which means that they're all contributing in terms of the definition of the respective factors. You'll see in this box over here on the right that we have the variances for all of the error terms. So that's why it says VAR, and it's got EE3, EE4, and so forth. And then down here you've got the variance for the emotional factor, the depersonalization factor, and the personal accomplishment factor. Next, you can see that we've got the covariances. First off, this is the EE3 DEP1 variable. So this is the covariance right there between those error terms. You can see it's not statistically significant. Then we've got the covariance between the emotional exhaustion and depersonalization. So there's a positive covariance there. And we have statistical significance, emotional exhaustion, and accomplishment. You can see there's a negative covariance and is significant, and then the covariance between depersonalization and personal accomplishment is also negative and statistically significant. Now typically you also want to look at the overall goodness of fit of the model. So what we can do is go up to statistics, post estimation. Most of the stuff you can use command language and it's a lot quicker, but if you don't know the command language, then you can just use some of these drop downs for post estimation right there. We can click on specification, diagnostic, and goodness of fit. So what I'll do is I'll go ahead and click on overall goodness of fit. And then statistics to be displayed, I typically just select all of the above and click on OK. And so now you can see that we have the goodness of fit statistics. So you can see we've got the likelihood ratio chi-square test right there. There's the chi-square value and the p-value that's given right there, and we have statistical significance, and generally that's considered an indicator of low or poor fit of the model to the data. This is kind of the chi-square test is actually kind of a historically has been used as one of the primary indicators. It was actually probably one of the first goodness of fit indicators. And but we also know that the chi-square test is impacted by sample size, and given that SEM is a large sample technique, it's not uncommon for there to be small errors in terms of, or small aspects of misfit, if you will, and this test be statistically significant. So basically statistical significance for this test is indicating poor fit. And so, but we also want to look at other indicators of fit, such as the Rmsea, the root mean square error of approximation. You can see the value is 0.096. Essentially, values that fall between 0 and 0.05 are indicators of close fit of the model to the data. Values up to about 0.08 would be considered indicators of acceptable fit. So you can see the Rmsea value that we have right here is 0.096, which is above 0.08. You can also see we have this p-close test right here. This is a test of whether the model exhibits close fit, and so this p-value is indicating statistical significance, and that would be an indication that the model is deviating significantly from a close fit, where we would have an Rmsea that would be less than or equal to 0.05. And just going back into my PowerPoint where I've got the where you can see things a little bit better, just kind of reiterating, there's the chi-squared goodness of fit test being statistically significant, suggesting poor fit, the Rmsea and the p-close test, both of those indicating poor fit. Then we've got the CFI and TLI, which are both incremental fit indices. Values that are greater than 0.95 would be considered indicating very good fit. Values at 0.90 or above are generally considered evidence of acceptable fit. So you can see both of these values as they appear in our table are below what would be considered acceptable fit. You can also see that we have the standardized root mean squared error of residuals, that's the SRMR, and so values up to about 0.05 are considered indicating close fit. Values between 0.05 and 0.10 would be considered acceptable fit. So you can see that we have a value of 0.088, which might be considered acceptable, but as we look at all of the other fit indices, we have evidence that our model is not really fitting all that well to the data. Now, if it's the case that we want to look at R-square values for each of our indicator variables to assess the degree to which the latent factors are accounting for variation in those indicators, we can go under the post-estimation selector again to equation level goodness of fit. So let me just kind of show you that. So we'll go up under statistics, post-estimation right there, and under our specification, diagnostic, and goodness of fit, we'll click on equation level goodness of fit. We'll click on OK, and so now you can see that we have R-square values, which would reflect the proportion of variation in the indicator variables that we have over here that's accounted for by their respective latent factors. So these are essentially communality estimates. Okay, so now if you want to also diagnose various errors of or areas within your model of potential model misspecification, there are a couple of options through the post-estimation selector. You've got matrices of residuals right here, so you can obtain the covariance residuals. You can ask for standardized residuals or normalized residuals. If you don't select either of those, you just get the raw residuals. I'm not going to go too far in depth with that. I'm just letting you know that those are possibilities. There are also modification indices that are available as well to evaluate possible respecifications of your model through the addition of parameters that might help to improve your model fit. So these are discussed a little bit more in detail within the PowerPoint, so be sure to check those out. Then finally, just to kind of reiterate that if you want standardized estimates in your diagram, if we go back and we rerun the model, under here, this is where we were selecting maximum likelihood estimation. If we go into reporting and select display standardized coefficients and values, you can see to the right over here, this is our model after requesting the standardized coefficients and values. So the double-headed arrows that you see within this diagram right here, these are now going to be correlations to the left for EE3 and DEP1. That's going to be the correlation between those two error terms, and to the right you can see the correlations between emotional exhaustion and depersonalization. That correlation is 0.52. Between depersonalization and accomplishment, it's negative 0.43, and between emotional exhaustion and accomplishment, the correlation is negative 0.18. If you go into the main output file, you can see that now our table that contains our factor loadings and so forth now contains the standardized estimates. You can also see that as you kind of scroll through the output file, you also see that now where it says the variance for the emotional factor, depersonalization, and personal accomplishment factors, now those variances are all fixed to 1. And you can also see that the correlations between the error term given right here and the p-value that's given, you can see that the correlated error is not statistically significant. You can see that this is basically the correlation between emotional exhaustion, depersonalization. There's the emotional exhaustion and accomplishment, and depersonalization and accomplishment factors. So those are all the values that were appearing in this particular diagram where we had requested the standardized estimates. Okay, so that pretty well concludes this video presentation on confirmatory factor analysis using Stata. Thanks for watching.